happy to have Chris King here to tell us a bit more about really what is the next stage beyond server and storage virtualization, and what's happening, what has been happening with new products, and what you see what's happening in the next year. And especially, what comes to mind to me is, if you don't need any more electrical engineers or guys who climb in the poles when you switch on the light, what will that mean for persons and skill sets you need in a data center of 1 or 2 years? So, Chris King, VMware.
Thank you. So, like Sudesh, I'll speak to you in English because I assure you, your English is much better than my Dutch. So yes, I think it's an interesting question about what's the career path for the folks who have been engaged in networking and security for the last 20 years. That's where I started my career, actually on the customer side, building networks. And I can tell you that the evolution of that role has never been more interesting. So I'll try to hit on that question as I kind of go through the comments I had prepared. And you know, what I'd like to do first is start with a discussion about expectations. And if you look at the expectation, you look at the typical executive in a large corporation, their personal experience with technology is very different than their professional experience with technology. So you think about who's the customer? Line of business executive, corporate executive, someone high up in the organization who is responsible for managing the risk-reward equation for a given organization. Their personal experience with technology is very different than their professional experience. And let me just tell a quick story to kind of illustrate this. So I spent a lot of time outdoors. I was hiking in the Sierra Nevada, which is a large mountain chain that separates California from Nevada and actually further up into Oregon and Washington. There's an area there that is famous in American history called Donner Summit. Some of you will be familiar with the Donner Party, which was a wagon train of pioneers who went west. And they had the worst luck available at the time. So they had storms and mud and all kinds of delays. And they got stuck at the foot of this mountain chain in the winter, and it was horrible. The blizzards came, the snow came, deep snow, got stuck. Very dark time in American history. They fell on very bad times, and actually it's one of the famous things about it. It was one of the few places in history where you have documented cannibalism. So kind of a dark chapter in American history. I'm out there hiking after a really bad winter, and I got lost. You can see where this story is going. And the snow was very deep. I lost the trail, and I was wondering how I was going to get home. And so I pulled out my trusty smartphone, and I fortunately had data coverage, was able to download a GPS mapping application, which had the trail that was 6 feet under the snow overlaid on the map. And so I was able to find my way home, get home in time for dinner instead of becoming a headline about getting lost and spending the night outside on Donner Summit. And I tell you this story really for two reasons. One is the technology that our executives use in their personal lives, and to some extent in their professional lives, but mostly in their personal lives, has two interesting attributes. One, that technology, typically that use results in instant gratification. And two, the function of that technology is software defined. So the role that my phone played in my life changed dramatically when I had a need. I had a need, I got instantly the thing I need, a map, an application to locate me on that map. And I was able to do what I needed to do. So again, software-defined, instant gratification. Now, you flip to the professional experience with technology. In a lot of cases, you have executives who they don't understand, and Sudesh had a great analogy. They don't understand the power generation, the power transmission, all the things required to get a service or an application or the automation of a business process to market. And they actually don't care. But the point is that they are somewhat used to this calendar perspective. You want a new function, you need a new function to conduct business, you need to wait. Now what happened was you had a lot of public services, a lot of public cloud services that pierced the veil. And they demonstrated the kind of instant gratification that executives came to expect in their personal life. Now it's available in their professional life. And so the expectation has been set that I should be able to get that same sort of software definition, that same sort of instant gratification in my professional role. So with that as kind of the backdrop, a lot of corporate executives are looking at this and saying, okay, I have a need for better, faster, more agile, and ultimately less expensive IT. And so I've got a choice. I can either do this new IT, or I can do no IT and send everything to public cloud services. Now the reality is, I talk to a lot of customers. The reality is, people aren't creating this stark choice, but marketing people like to demonstrate kind of black and white, simple choices. And the point is that I have a lot of customers who are hedging. They're trying to build new IT while at the same time employing a no IT approach very tactically. Now, the interesting thing is there is a black and white choice similar on the IT side. On the IT side, there's been two interesting alternatives proffered by the industry. On one hand, and this is the hand that VMware is on, you have the software-defined data center. And I'll explain more about what that is in some detail in just a minute. But the basic idea is you virtualize compute, network, storage resources, and you provide automation and programmatic interfaces and management around that. Or the other way that folks have talked about it is a hardware-defined data center, where you infuse the infrastructure with lots more intelligence. And those are the two alternatives that have been proffered for this idea of a new IT. And I'm not using the word cloud here, but basically that's what we're talking about. Now, let's take a kind of a historical look at this. So if you look at the biggest, baddest data centers on the planet, the most scalable, the most flexible, the highest performance, the most agile, Google, Facebook, Amazon, the web giants, what they've done is to virtualize capacity. Networking capacity, storage capacity, compute capacity. They've virtualized this. And on top of that, they've built a platform that takes advantage of that virtualized infrastructure and effectively says, I'm going to put all the configuration state in software. Now the problem is, that platform is inextricably bound to their application. So what VMware did is said, what we need to do is make this available for any application. And in fact, if you talk to some of the web giants, you talk to their internal enterprise IT, they're speaking to VMware about how they can do what they've done on their business side the same way they've done on their network side. But basically, this idea of the software-defined data center says, let's build an SDDC platform on top of any capacity that you have underneath. And this could be, motherboards Velcroed to racks, a la Amazon, or it could be your standard existing hardware plant. But let's build this virtualization platform that contains the configuration, the state, the management, the automation, all in software. And let's make that available for any application so the application can use it without modification. The application will see all the things that it expects to see, from x86 to TCP/IP stacks to storage and so on and so forth. You contrast that with a hardware-defined data center, which basically rebinds all of that functionality into hardware. And I think the other historical perspective I'll provide here is that if you look at the history of computer science, I go back a ways. I didn't code in machine language, but I appreciated the change from machine to assembler to 4GL. If you look at when operating systems came onto the scene and application developers could write to OS as opposed to writing to chip. when you put things like more application-level networking protocols into place that abstract some of the basic TCP/IP services. The point that I'm making is the history of computer science is filled with examples where we've inserted abstraction and abstracted a resource, and rapid innovation ensued. So if you think about the advent of an operating system or the advent of server virtualization, what happened was application developers were able to innovate at a very rapid pace. The interesting side effect was the underlying hardware was able to innovate at its native pace. So Intel could move as fast as their fabs would allow them. And this insertion of the abstraction layer is exactly what we're doing with the software-defined data center and bridging the entire data center to make that an abstracted, pooled, automated resource. Now, there's one other interesting advantage. And as I said before, the execs I talk to, they're not abandoning internal IT for the most part. But what they want are options. You talk to most executives, they love options, they love choice, they love the idea that I don't know what's going to come along in the regulatory environment, in the business environment, from a competitive perspective, and I may need to react. And the better and faster I can do that, the happier I am. And so one of the interesting things that a software-defined data center approach does is it creates those options. So I talked to a large financial services organization in the Netherlands yesterday, and they said, we think we want to start moving lots and lots of things into the public cloud. And I would argue that a software-defined data center approach actually enables that. It enables that option. Another example that I talk to executives about is merger and acquisition. If you look at merger and acquisition attempts to buy companies, they are often fraught with IT risk. And some of that risk is data and application integration, but some of that risk is the need to rip and replace entire infrastructures. And the idea behind a software-defined data center is the underlying capacity is not brand dependent. So if one organization has a Juniper network and the other organization has a Cisco network, bringing them together, stretching a software-defined data center construct across both of those physical plants is actually easy. So this idea of a hybrid approach, it's never as clean as there's only private cloud and there's only public cloud. Most organizations are going to have a hybrid approach. They're going to use some private resources, they're going to use some public resources, and the goal of VMware is really to create a single SDDC construct across multiple piles of hardware capacity. And this is where we see a lot of organizations taking up the mantle of software-defined data centers. That's exactly what I want to do. So the missing piece in all this has traditionally been the network. If you look at a lot of the developments in the data center, early days of server virtualization, it took 30 to 45 days to provision compute. It took 7 to 14 days to provision networking and security. So the networking folks were feeling pretty good. Along came server virtualization. It took 30 minutes to provision compute. And all of a sudden, the 7 to 14 days, and by the way, 7 days is pretty darn good for provisioning physical network and security services. All of a sudden, that week or two starts to look pretty long. And so what you see is a lot of automation, a lot of compute virtualization, a lot of storage virtualization. The missing piece has really been the network. And I want to spend the next couple minutes talking about how VMware sees that changing. So the basic idea of network virtualization is not, a new networking protocol, is not a way of configuring hardware. The idea is to lift a lot of the configuration state, the logical connectivity, the switching, the routing, the intelligence out of the hardware and instantiate it in software. What this enables you to do is to treat an entire data center network like a VM. You can back it up, you can restore it, you can trash it. You can build your network in a bunker and push it out to a trailer. And in fact, we're talking to many first responders in government for disaster relief, where they want to do exactly that. I want to build my network in a bunker, and when the time comes, I want to push it out to a trailer. The entire data center network with all the applications and everything associated with it. But this idea of treating an entire network like a VM is basically what we're talking about with network virtualization. And a lot of people scratch their head and say, wait, when I think of my network, I think of switches and routers. I don't understand that. So let me spend a minute on that. The idea with a virtualized network is you still have a physical network, but that physical network gets simplified. And you do all the interesting things in software. So think about your network today. You have compute, you have networking that connects those hosts, and then you have a bunch of services that go over top of it. You also have a hypervisor and a vSwitch, which is the important foundation for network virtualization. So what we're able to do is to take that vSwitch and push services down into it. So this diagram here, think of that box in the middle at the top. That is a logical container. There's no actual instantiation of that. That's my list of services that I can pull from. So I'm sitting at my cloud management platform, and I spin up some new VMs, I spin up some new applications, and I have this thing called an NSX controller, a controller that basically contains a normative model, a prescriptive model for the state of the network. And by the way, that's interesting in itself. That's really never existed before. The only normative model for most networks exists in the architect's head. But the cloud manager says, I need to provision new services. The NSX controller pushes that normative model down into the vSwitch, and the vSwitch instantiates L2, L3, L4 through 7 services like firewalling and load balancing. And the way that works is, let's say I've got these two VMs that need to communicate, and these two VMs, the green ones, are layer 2 adjacent. They expect to be right next to each other, even though they're on other sides of the data center. And the way we do this is we actually configure them as L2 adjacent, and we use an overlay technology across the physical network. So this is an overlay, a lot like a VPN or a VLAN or MPLS. Overlays are part of networking and always have been. But what we're doing here is we're encapsulating it across the physical network and then decapsulating it at the other vSwitch. So effectively using that physical network as a simplified backplane. And for those of you who are familiar with network chassis, you don't do any configuration on the backplane. The job of the backplane is to get packets from point A to point B, or line card A to line card B as fast as possible. You do all the configuration and interesting things on the line card. Think of the physical network as the backplane, and the vSwitch as the line card. And that's where you're going to get a lot of this benefit. The advantage here is I can have L2 adjacency across the data center, and I can have logical isolation within a host. So the blue VM that you see next to the green VM actually doesn't have any connectivity and doesn't even know the green VM exists. This is, when you start to internalize this gets really powerful. So, let me give you another example of one of the benefits. A lot of you will be familiar with diagrams. This is a traditional 3-tier Cisco network using Nexus 7Ks and UCS. If you look at a traditional way of communicating east-west, for routing, for example, I have to go all the way to the core. And by the way, when I go all the way to the core, I traverse what are oversubscribed, very expensive links to get to a VM that might be right next to me. With NSX, I distribute layer 3 routing. So I don't even have to leave the host in a lot of cases. I go up to the access layer. I don't even have to hit the aggregation layer. On the right-hand side, let's say I'm on different blades, different hosts. I might have to go to the aggregation layer, but I don't have to go all the way to the core. So this has a tremendous effect in preserving the existing networking capacity. When I start doing things in a distributed fashion, I can do routing in this distributed fashion. I can do firewalling, basic firewalling capabilities in this distributed fashion. So this is a very, very powerful thing in terms of preserving the existing and making the best use of the existing physical network. So I expect this to raise more questions than answers. This is kind of an interesting technology, and to the point that Jan made earlier, there's a lot of interesting career opportunities here. But I want to spend just a couple of minutes on security if I can, because this is where we see folks adopting. And this is, John's going to talk about this in a few minutes, but the idea of the hard, crunchy outside, soft, chewy center for data center security is traditionally the problem. People have talked for a long time about compartmentalizing the network. It's operationally very challenging. And one of the things that NSX does, and network virtualization does, is to create this idea of a distributed firewalling concept. Not a physical firewall where there's a place, or a virtual firewall that has the same operations model, but the idea of firewalling that's baked into the infrastructure. So those, again, those vSwitches get used. And what we're able to do is to deploy 3 models of security. Pure isolation, production, development, test, those kinds of things, where they have overlapping IP addresses and aren't even aware of each other. Same thing's true in service providers that have multi-tenancy requirements. Segmentation, where I have connectivity between web app and database tiers, but I have security controls associated with that east-west traffic. And I have this ability to insert value-added advanced services like Palo Alto Networks into that same infrastructure, into that same operations model. And by the way, when the VM moves, all the services move with it. So this makes this idea of microsegmentation operationally feasible. This makes the idea of zero trust operationally easy to deploy. So we've got high-performance firewalling in the hypervisor. We've got the automation that goes with that. So when the VM travels, the services go with it. When you decommission the VM, the services disappear, so your firewall rules disappear. You don't have that firewall rule sprawl. And third, you have this ability to insert a lot of advanced services for security into that same bucket. And what you see is, obviously, the banks are all adopting network virtualization. The interesting thing is, on the right-hand side of that slide, you have a whole bunch of what I'd call regular companies, regular organizations, from government to retail to manufacturing, that have adopted NSX for the very specific reason that I talked about, which is security. So they're going to get the agility, they're going to get the speed, they're going to get the benefits of network virtualization, but they're doing it first because of the security benefits. So the idea here is going back to that personal versus professional experience to get everybody a watch, and that watch ends up being software defined. So on that sort of minutes time frame, in a way that the business can consume it. And for those of you who were living in a cave, that's the new Apple Watch that was announced and may show up next year. So I'm a couple minutes over time. Thank you. Hopefully this has been useful. Both ON2IT and VMware folks are around for questions afterwards, and as I will be. So I thank you for your time and your putting up with my English.